Okay, this is 8.2 similarity transformations. When you finish, you're going to be able to perform a similarity transformation. You're also going to prove that shapes are similar after their transformation. Here's a couple definitions for you. Similar figures, that's where angle measure is preserved and the side lengths are similar or proportionate. Similarity transformation is a dilation or a composition of rigid motions or dilations. So what we're talking about there is you're going to take a shape, for example, a triangle, and you're going to move it up, down, left, or right, or you could possibly reflect it across the x or the y axis, or rotate it 90 degrees, 180 degrees, 270, and also shrink it and enlarge it. So we're doing a lot of different things here. We're going to take you through a couple examples, and then I think that will help you a little bit here. Right here, we're starting with triangle ABC, and here's our original ordered pairs, which are mapped out on the graph. And what we're going to do is we're going to translate it to the right 5 and up 1, and then we're going to dilate it, so we're going to enlarge it by a scale factor of 2. So our scale factor is 2. So we're going to do two things here. So first what we're going to do is we're going to fill in the ordered pairs of our prime by taking our coordinates. So we're going to add 5 and add 1 to our x and our y. So A is negative 4, 1. So 5 minus 4 is 1, and 1 plus 1 is 2. So our new A prime is over 1 and up 2. That's where our new A prime is going to be. Our B prime is negative 2, 2. So 5 minus 2 is 3, and 2 plus 1 is 3. So then our B prime becomes over 3 and up 3. That becomes our B prime. And our C prime is negative 2, 1. So 5 minus 2 once again is 3, and 1 plus 1 is 2. So we go over 3 and up 2. So that's our first transformation. Everything in the x direction, we moved it to the right 5, and then we went up 1. So if I redraw this triangle now, as you can see here, we've shifted this triangle to the right 5 units, and we've shifted it up 1 unit. So that's our plus 1, that's our plus 5. Hopefully that makes sense. Now we're going to enlarge it by a scale factor of 2, as we mentioned before. So what we're going to do here is we're going to times our x and our y by 2. And that's going to become our red shape, or our A double prime, our B double prime, and our C double prime. So A double prime, 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, and 3 times 2 is 6 again, and 3 times 2 is 6, 3 times 2 is 4. So that's our new shape. So then we go ahead and graph that. We go over 2 and up 4, and that becomes our A double prime. We go over 6 and up 6. That becomes our B double prime. And our C double prime is over 6 and up 4. And that becomes our new shape. Notice it's larger by a scale factor of 2. It shifted to the right and up 1. Okay? So that is how you would how on your paper you would indicate what's going on, where we translated it first, we shifted it right 5 and up 1, and then we dilated it after that. So that's our new images. Here we have a similarity transformation of a trapezoid. We're going from PQRS to WXYZ. So as you notice here, the orientation is different. If we tried to rotate this shape around, it wouldn't rotate on top of itself. It is smaller as well. The first thing we did is we reflected it across the x-axis. So we're taking this ordered pair of P, which is negative 6 and 3, and we reflected it across the x-axis over here to positive 6, 3. So the only thing that changed is the x coordinates all were multiplied by a negative. So they're opposite. So negative 6, 3 becomes positive 6, 3. And right here we have negative 3 and positive 3, and it becomes positive 3, positive 3. So that becomes the new, if you will, P prime, Q prime. And we just go ahead and finish our translated image. This would be S prime, and this would be R prime down here. And then you can see the green shape. Now our orientation is the same. Our trapezoid is pointing the same way. We just need to shrink it. So looking at it, this shape has a measurement of 2. This one has a measurement of 6. So if we do the new over the old, it's 2/6, which is 1/3, which is our scale factor. So what would happen here to map the red onto the green, we would times each of these ordered pairs by 1/3. So just for example, 6 times 1/3, 6/3 is 2, and 3/3 is 1. So if you'll notice, over 2 and up 1 becomes our ordered pair right there. And if you do the same thing all the way down, you have 1 and 1, 0 and -1, and 2 and -1. And that's our new ordered pairs for our final shape. So we reflected it and then we dilated it is what happened here. And notice above the arrows we put what we're doing, what transformation we're doing there in order to make our new shape. Here are some transformation rules that we would like you to write down, take a picture of with your phone, write them in your notebook, whatever you're doing. You're going to need these as you do the assignment today. And the assignment will be just as it was yesterday. It'll be on the Big Ideas website. It'll be in your book. The problems should be assigned there for you. Go ahead and try some of these. Try and reflect them, rotate them, and dilate them. There is some examples, and there's also examples on the Canvas. If you didn't follow some of these examples, maybe you can follow some of their examples and give you some more information.
Okay, now you have to come to your magic of where it is.
Oh. And save it and name it.
Yes.
Okay. So, it's right here.